Create the position curves for the beams. Curves on a surface. So the name of this component, contour, it will take a surface and then it will create curves along that surface based on a point. Let's give list, and let's give one of these points we referenced here. Let's give this one. It's the first element in the list, and input it here, and then the direction of the curves. So for that we use vector, and let's define 1 and the rest will be 0. Let's see what, okay, indicate, it's already 0 and this is 0 as well. Let's give this the direction, and now we need to indicate how apart these curves will be. So the distance, let's give again a generic, and 20. Yeah. So we created the curves along the X on this surface. We can change the angle of these curves by defining y and x vector, unit vector, so like this. And then let's create the curves on the other direction. By defining it -1, changing the direction of this vector, and then we have sort of a mesh, or we have a net-like curve structure. Of course, we need to define the same for the second column, around the second column as well. Let's drag this a little bit down here, and then we can maybe set this integer as 2, and then copy paste the whole definition. Just adjust. Okay, let's keep the point as the same. So then we position everything similarly. So let's check. Yeah, instead of the previous surface, we need to plug this surface in. Yes, and we basically created the whole set of network here. So we need to give a thickness to them. So let's see it again. Yes. So if we merge this curve sets, instead of individually having the list of these networks, we calculate the whole geometry by merging the data that comes from these curves. So let's define the profile. We use a component called perpendicular frames that generate a number of equally spaced perpendicular frames along curves. So in this case, the whole geometry need to go into here. So let's see how many numbers. So 10, maybe 10 is not enough. We need to give maybe 100, so the resolution of the curves will be better. So aligning the curves, that is true and it's correct. For now, we created the frames. We need to define the section of the profile geometry. So polygon, it needs planes, in this case the whole set of planes, and radius, segments, and fillet radius. Segments, if we want to have a rectangular profile, like in the examples, if it's a wooden beam, so it's generally rectangular. So we can just set this as 4, and then this component will calculate a rectangle based on the curves, based on the frames over here that is created. So, and the size, basically, let's say 5 in 5 centimeters. And we will loft again. So there is also a part on the ceiling that covers the holes as well. If you don't want to cover this structure like this, you can basically use the strategy by dividing the ceiling into two parts, and then feed that half of the ceiling structure into the loft in here. So then merge them together. Let's create the points for the ceiling. Clear values and copy paste these ones. I just indicate very quickly the numbers. Yes, and one by one. Referencing the points. Line. And middle. So this one, and then copy paste this one. Reference, and then reference this point, calculate the line between them, calculate the middle point. Yes. So let's create a point list for the first part. Shift. So this will go over here. The first one. Let's drag this a little bit, and then take this part add to the group, and second point list. We created the references for the second boundary, and copy this like this in here, and then yes, I created two boundaries, and then this will go in the loft in here. This will be the part of the ceiling, and this will be the part for the creation of the funnel, and see the loft and these. You can still merge, use this part, and then yeah. And of course there should be a joining beam over here. Which is and let's define the frame. And this frame should be a closed curve, loft options, closed loft, non-normal, and then there are some strange parts here. So let's try to use these options. True this time, and maybe the resolution is not enough, so we can multiply it, let's say 2, which means that it will be, which means that instead of 100 there will be 200 frames that will be created, so should be enough for better loft, and it worked. Oh yeah, it's again a bit something that we don't want to see, so instead of 2, let's say 5. To correct this loft, we can we can increase the resolution of the frames. So let's give it 1000 for the amount of the planes to be created here instead of 100. And then just click much better. If you merge this two, we will have we will delete the identical line that is shared by this two frame, and then if we love this, if we use this one to the frames and then love the structure, so then we will have a frame around we can actually close this whole preview, selecting all and then preview off and preview, custom preview, and the geometry is the lofted geometry. And then by color swatch, we can just select a color we like, a little bit brownish, we can select that, and we can adjust the transparency, and we can have actually a preview of the colored wood structure. And let's open. This should be in as well. You can basically adjust the beams. So you can change the radius for the columns. So this is, let's make it really thin. Or thicker. Let's keep it 50.